We live in a world full of invisible maps. Beneath our cities lie hidden rivers, forgotten tunnels, and mineral veins. Inside our bodies, neural pathways and blood vessels form intricate networks. But our tools to see these hidden landscapes are limited. They often require digging, cutting, or powerful radiation. What if we had a new sense? A way to see not with light or sound, but by feeling the faintest tugs of gravity or the whispers of magnetic fields. Welcome to Boson Buzz. I'm Monty Molecule, and today we're exploring a new way of seeing. We're meeting the masters of the invisible world, the Quantum Cartographers. Our story begins in an ancient city, where historians suspect a network of hidden catacombs lies beneath the modern streets. Using ground-penetrating radar or digging trial holes is slow, destructive, and might miss delicate structures. They need a way to see through meters of solid earth without disturbing a single stone. This is the perfect job for a quantum gravity gradiometer. It sounds complex, but the idea is beautiful in its simplicity. Everything with mass, you, me, a rock, an empty tunnel, has gravity. A dense object, like a stone wall, pulls slightly harder than an empty air pocket. Normal gravity is far too weak for us to feel these tiny differences. But a quantum sensor uses the bizarre rules of the subatomic world to measure gravity with insane precision. Think of it like this. Imagine you are blindfolded in a room, trying to map the furniture by feeling the air pressure on your skin. Impossible, right? Now imagine you have a feather so sensitive that it can feel the tiny drafts of air flowing around each piece of furniture. That's what a quantum gravity sensor does. It doesn't measure gravity's full force. It measures tiny changes in gravity from one spot to the next. As you scan it over the ground, the reading dips slightly over a hidden tunnel, less mass, and spikes over a buried stone foundation, more mass. By walking this sensor in a grid over the ancient city, the quantum cartographer doesn't just get hints. They get a detailed 3D picture of the underground world. On their screen, the buried catacombs appear in clear relief, snaking beneath churches and parks, all without a shovel ever breaking ground. How can it be so sensitive? It uses a trick from the quantum world called superposition. Inside the sensor, a cloud of atoms is cooled to near absolute zero, making them incredibly still. Then, they are put into a special state where they exist in two places at once, a quantum split. As these split atoms fall under gravity, the half of the atom that's closer to a dense object feels a slightly stronger pull than the half that's farther away. This tiny difference changes how the atom behaves when it's put back together. By measuring this change in millions of atoms, the sensor builds a picture of the gravity landscape below. It's not using a ruler, it's using the universe's own rules to measure itself. This ability to feel density changes has another incredible use: seeing underground in real time. Imagine monitoring a volcano. By placing permanent quantum sensors on its slopes, scientists could create a live 4D map of the magma chamber below, watching as dense rock melts into less dense magma and rises, giving perhaps weeks of warning before an eruption. It turns the solid ground beneath our feet into a transparent window. But gravity is just one invisible force. The quantum cartographer's toolbox also includes supersensitive magnetometers. Our planet has a magnetic field, but local fields are distorted by buried metals, archaeological hearths, or even the faint magnetic signature of baked clay pottery. A quantum magnetometer can detect these distortions with pinpoint accuracy, revealing the outline of a sunken ship under sea mud or the foundation of a long-vanished wooden fort. Now, let's apply this sight to a different living map: the human brain. Doctors need to understand brain activity to treat epilepsy or prepare for delicate surgery. Current methods like fMRI are expensive, require giant machines, and can't track fast changes. EEGs are fast but fuzzy on location. A new kind of quantum cartography is emerging for the body. It uses a related principle to map the incredibly weak magnetic fields produced by electrical currents in our nerves and hearts. A person wears a lightweight helmet embedded with an array of these ultra-sensitive quantum sensors. As they think, speak, or move their hand, the electrical fireworks in their brain create tiny magnetic ripples. The sensor array catches these ripples and maps their source in real time, creating a dynamic, high-definition movie of brain activity. Let's see it in action. An archaeologist in Italy scans a grassy field rumored to contain a Roman villa. The quantum gravity gradiometer, mounted on a small cart, is pushed back and forth. With each pass, the map on the tablet grows clearer. Walls, rooms, and even the outlines of a central courtyard garden emerge from the noise. The team now knows exactly where to excavate, saving years of guesswork and preventing damage to priceless ruins. Meanwhile, in a hospital, a child being evaluated for epilepsy wears a sleek sensor helmet. They play a simple game. Doctors watch a screen where colorful lights bloom and move across a 3D model of the child's brain, showing exactly where and how a seizure begins. This precise map allows for targeted treatment that could stop the seizures without affecting healthy brain tissue. The future mapped by these tools is one of profound transparency. Geologists could use airborne quantum gravity surveys to find freshwater aquifers in drought-stricken regions or locate critical minerals for batteries without scarring the landscape. Engineers could scan aging bridges and dams from a distance, finding internal cracks and rust before they become visible and dangerous. On a grander scale, this quantum sight could peer into the very structure of matter or detect hidden chambers in the pyramids of Egypt with unprecedented clarity. It gives us a gentle, respectful way to explore whether the territory is a historical site, the human body, or the planet itself. It offers us a new kind of vision, beyond light and sound. The Quantum Cartographer teaches us to see by feeling the universe's most fundamental forces. It promises a future where nothing useful needs to remain hidden, where we can find water, understand our minds, and uncover history, all with a gentle, probing touch. If this idea of mapping the invisible world intrigues you, please like and subscribe to Boson Buzz. Until next time, have a safe and curious week.